Hello, welcome to another video lesson. This is Mr. Rosia, and in this lesson you are going to be introduced to special right triangles. So today we'll be discussing 45, 45, 90 in this video, and then in the following video you'll learn about 30, 60, 90 special right triangles. Okay, so let's start with a square here. So what I'm going to do is I'm going to draw a diagonal, okay? And when I draw this diagonal, the diagonal is going to bisect this angle and this angle. Since each angle is 90 degrees, then we end up with 45-degree angles here and here. So we have four 45-degree angles. So what I'm going to do next is I'm going to just get half of the square, okay, and then you'll see what we end up with once we take just half the square. And this is not drawn to scale, okay? I'm just trying to give you a visual here. All right, so then I'm taking this triangle here. So this angle is 45 degrees. This one is 45 degrees. And this one here is the right angle. Now, whenever we do this, don't forget that on a square, all sides are equal, which means this leg is equal to this leg, okay? So since they're equal, let's just call them, this is leg x, and since this is leg x, then this is also leg x. Now, the question is, what is the length of the hypotenuse? So if each leg is represented by x, how can we know what's going to represent the hypotenuse here? And I'm not expecting you to know this, okay, but I'm going to show it to you. So if we apply Pythagorean theorem, and I'm going to try to show you this picture at the same time with the work that I did here, okay, that might be better. Since each leg, this is a and this is b, so this is a squared plus b squared equals c squared, okay? So notice that instead of a and b, since they're both equal, I have x squared plus x squared equals c squared. We don't know what the hypotenuse is, and also we don't know what the legs are, but we're just trying to come up with the formula to help us determine what this is going to be. So as you know, these two are like terms, and from algebra you learned that if you have two like terms, you just combine them. Okay, so in this case, x squared plus x squared gives you 2x squared. So that equals c squared. Now, we don't want c squared, we want c by itself. So then we take the square root of c squared and also the square root of 2x squared. But when you take the square root of x squared, you have an x that comes out of the square root, but the 2, it's going to stay inside. So then the hypotenuse is represented by x square root of 2. So this hypotenuse is x the square root of 2. Again, I'm not expecting you to memorize this or know this, but this is why this is x the square root of 2. So I'm going to use this in the following examples. Okay, so let's go over example number 1. So if you look at example number 1, as you can see, this angle is 45, this angle is 45. That means this leg has to be equal to this leg. So we have the leg is equal to 9. The question is, what is the length of the hypotenuse? And if you follow this pattern here, the value of x in this case is 9, which means the hypotenuse has to be 9 square root of 2. Okay? And if you didn't catch that, if you need to, pause the video and copy what I've gone over, and hopefully that will make it easier for you. So let's continue on to the next example. And for some reason, I made a mistake here. Let me just fix this real quick. Let me just correct that. Okay, so we're given that this is 3 square root of 2, and we're given that these two are equal, so that means we have 45, 45, 90 special right triangles. Because these two are equal, so it's something that I forgot to mention is that these triangles are isosceles right triangles, okay? So maybe that'll make it easier. So this is 3 square root of 2. So the leg is given to have a measure of 3 square root of 2. Now the question is, what is the length of the hypotenuse? Okay, how can we determine the length of the hypotenuse given that the leg is 3 square root of 2? Now, follow this pattern again. This is 3 square root of 2. This one is another square root of 2. So what I'm going to do is I have the leg, and then I'm going to multiply the leg by the square root of 2. So times the square root of 2. So what happens here is all you do is you multiply the radicands, meaning the numbers inside of the square root or the radical. Okay, so this is square root of 3 times square root of 2 times 2. That's equal to 4. And as you all know, the square root of 4 is 2, right? So 3 times 2, which is equal to 6. And this is what we're trying to find. Okay, that's the length of the hypotenuse. All right, let's move on to the next example. So for this one again, we have the leg is equal to the 5 times the square root of 6. So then the hypotenuse has to be equal to 5 times the square root of 6 times the square root of 2. So it's similar to the second example. Okay, so then again, this is 5, and then 6 times 2, that's equal to 12. But 12, from the previous lesson on Pythagorean theorem, we can break this into 3 and 4. And I hope you guys remember that if you take the square root of 3, that's a prime number. The square root of 4, that's not a prime number. Okay, so we know that the square root of 4 is 2, so the 2 will be coming out of the radical, but the 3 is going to stay inside, okay, because it's not a perfect square. And then we multiply 5 times 2, which is equal to 10, and keep the square root of 3 next to it. And that's the length of the hypotenuse. Okay, let's go on to example number 4. Example number 4, we're given the hypotenuse, okay? So again, don't forget. So what you need to do here is, okay, what's the value of x in this case, which is the length of the leg? So let's look back at the pattern. This is x, this is x, this is x square root of 2. Okay, so let's go back to this problem. And as you can see, we have x square root of 2. So this is the value of x. So I'll just write an x here for now. So then the leg has to be equal to 8 units. Okay. All right. I hope that makes sense for this problem. Let's go on to number 5. So for number 5, notice that we're given the hypotenuse. The hypotenuse is 12, but we're used to seeing this as x square root of 2. Okay. But what happens if you have a whole number? So what I would do in this case is I would set up an equation on the side. So I'm going to do the work here. I'm going to say x square root of 2 equals 12. Okay, and I'm going to solve for x. So I'm going to use algebra, my knowledge of algebra, to solve for x. So I'm going to divide by the square root of 2. And then we find that x equals 12 divided by the square root of 2. Now, I know you haven't seen this before maybe, okay, but in algebra, we are not allowed to have square roots or radicals in the denominator. So what we do is we rationalize the denominator, which means this square root is irrational. So to rationalize it, meaning to convert it or change it to a rational number, we multiply by the square root of 2. So whatever we have in the denominator, multiply by that same radical, okay? So when we do that, we have now x equals 12 square root of 2. Now we have it in the numerator, but when we multiply the square root of 2 times the square root of 2, we end up with the square root of 4. But the square root of 4 is just equal to 2, so then this is 12 square root of 2 divided by 2. And now we can simplify this even further, because how many times does 2 go into 12? And if you said 6, then you are correct. Very good. So this is 6 square root of 2. So now the leg here is 6 square root of 2. Okay? I hope that this video helps you understand and also complete the assignment. And again, don't forget, we're just an email or a remind message away. All right. I'll see you in the next video. Bye-bye.